Hello and welcome to the Regenerative Acceleration performance explanation video. This is for the computer software development guys and anybody else who wants to understand the backing theory on regenerative acceleration, ReGen-X coil performance. So if we look at a conventional coil is a low impedance coil. It stores energy in the electromagnetic field around the coil, and this electromagnetic field produces polarity which is identical to the approaching magnetic field. So when the rotating magnetic field is approaching the coil has an induced magnetic field in it which is identical to the approaching magnetic field, and the identical magnetic fields resist each other. Now when the rotor is moving away, the current direction in the coil changes and the polarity of the magnetic field changes from identical to opposite, and the coil opposes the permanent magnet rotor's departure from the coil. And this is denoted in Lenz's law by the minus sign, which simply states that for every action there's an equal and opposite reaction. Okay, so the regenerative acceleration coil is a high impedance coil. It stores energy in the electrostatic field inside the coil between the wires and operates as a capacitor. So what we have is when the permanent magnet on the rotor is approaching the coil, the impedance in the coil is high enough that current cannot flow in the coil. And because current can't flow in the coil cannot produce a repelling magnetic field to resist the coil's approach. When the coil is top dead center to the coil and just about to start moving in the other direction, the current in the coil must change direction. When the current in the coil changes direction, the induced voltage in the coil, which is maximum at top dead center, is able to be released through the low DC resistance of the coil. And this release of the stored voltage in the coil produces a maximum magnitude repelling magnetic field which is identical to the rotor's magnetic field, which is now moving away. So the magnetic field that's produced inside the coil is delayed until top dead center and then released with a maximum magnitude which pushes away on the now receding magnet and attracts the opposite pole which is coming into position. And this is where the acceleration comes from. And if this was denoted in Lenz's law, the minus sign would be changed to a plus sign. So now we have an equal and equal reaction. So as a circuit diagram, we have our rotating magnetic field, which is producing current through our coil, and our coil is creating a magnetic field. At low frequencies, the self-induced capacitance is also quite small. It's negligible. Now, as the frequency increases, the impedance of the coil increases, and the self-induced capacitance also increases in the coil. So the impedance goes up, the current flow through the coil goes down, the repelling magnetic field produced in the coil also goes down, and the coil is gradually storing energy as voltage rather than storing energy in the electromagnetic field. So eventually, once you hit the critical minimum frequency for the coil, there's no current flowing through the coil, there's no repelling magnetic field, all of the energy is being stored in the self-induced capacitance of the coil. When the rotating magnetic field on the rotor is top dead center, the induced voltage in the coil is maximum. At this instant in time, the stored voltage in the self-induced capacitance of the coil can now be released through the low DC resistance of the coil, producing the maximum repelling magnetic field that we talked about here at top dead center, and the current flow through the coil is now maximum. And once the magnet moves away and the south pole begins to approach, then the process is repeated. And I also want to state that the DC resistance of the regenerative acceleration coil does not need to be huge. This is a regenerative acceleration coil that has a DC resistance of 2.6 ohms. So, and it creates regenerative acceleration at its own critical minimum frequency. Each regenerative acceleration coil has its own critical minimum frequency. So the initial acceleration point that can be derived by the regenerative acceleration coil can be altered by changing the impedance of the coil. This is another regenerative acceleration coil that uses thinner gauge wire, a higher DC resistance, and it will produce regenerative acceleration at a lower RPM than this coil. But this coil will produce a larger magnitude of current through the load. So depending on what the application is, the coil has to be designed accordingly. Thank you for viewing. Cheers.